So if we have our ARP responses, we know who they are. Is there some place that we can actually see the address resolution? Can we see the MAC address to IP mapping? Sure, PCs, routers, we all maintain an ARP cache, and we can actually take a look at the ARP caches to see where the data is stored and what the values are. Let me bring up a packet tracer. So packet tracer is the lab infrastructure that you've been working with. I created a little infrastructure that I use for demos and for testing purposes, where I've got a couple of routers connected with a serial cable here, a couple of switches, a PC, a laptop, and a server that's all set up. All I've done is built the lab infrastructure, and I gave IP addresses by the diagram. So the left network, over on the left-hand side over here, is all the 192.168.10 network. And so the router interface itself is 10.1. That's the Ethernet segment. So this broadcast domain is defined as with the default gateway. My router out is 192.168.10.1. I do have a serial connection here between router 1 and router 2. Again, on the 20 network, so 192.168.20.1 is router 1's Ethernet interface. 20.2 is router 2's Ethernet interface. And over here on the right-hand side is the 30 network with 30.1, again standard. In most companies, we use the first address in the range for our router interface. So the .1 interface would be R2's Ethernet interface. And then down here, my server is 30.200. On the left-hand side, my PC is 10.100 and the laptop is 10.105. So if we look at the overall ARP infrastructure, what actually happens here like we did before? I did a demo and I drew a picture for you how the ARP process worked. And again, that's exactly what's going to happen with the PC. If I want the PC to ping R1, what's going to happen first is there's going to be an ARP packet that comes out of here. PC1 is going to go, router 1, you are in my network, so router 1, give me your MAC, or 192.168.10.1 ARP request. The packet will come out of the PC. It will go up to the router. The router will recognize that broadcast. Now the laptop's going to hear the broadcast too, but it's not going to respond because I'm actually asking for the MAC address of .1 as an IP. The router will respond back to my client machine. Now the way that we put it together as the standards go, I don't have to do this every time. If I've just asked you for your MAC address, I don't need to go back every single time and ask you. I'm going to keep it in a local cache, at least for a while. If I look at my PC, let me bring the PC interface up. Oop, that kind of grabbed out of running off the screen there. Let me see if I can make that a little smaller. There we go. That actually fits in here fine for me. And I'll get rid of the little pink lines. We don't need them for now while I'm looking at my PC. So I'll go back to my PC. If I look at the desktop, I bring up a command prompt. I can look at my ARP by doing an ARP-A. Those are the addresses. And there are no ARP entries. Well, I haven't done anything yet. There's nothing for me to learn. If I want to ping my router, ping 192.168.1.1, we said was the router. No, we didn't say .1.1 was the router. .10.1 is the router. Little mistype there. So we'll wait for this to time out. We'll do 192.168.10.1 as our ping, and that will work for me. So what my machine did, my PC, did an ARP request for the IP address of 10.1, for the MAC address, I'm sorry, of 10.1, and then it stores it here locally. So now if I do an ARP-A, I can see that the IP address of 10.1 maps to the MAC address of 0009. 7C254401. Again, notice how Cisco does their notation here in the groups of 16 bits rather than 8 like the rest of us do. It doesn't really matter. It's just it's just a formatting piece. So that's how the PC, that's how a Windows PC will display that to you. On the router side, the router's going to do the same thing. So if I go to my router, let me bring that back down in the screen here. Go to the command line interface for my router, and bring it up and do a show IP ARP. It's going to show me the mapping of 10.1 and 10.100. 10.1 is the router's fast Ethernet interface, and 10.100 was the PC that just did that. Just did what? it did the ARP request. Well, remember, I'm doing a ping. So what I actually tried to do was do a ping packet. But in order to build my ping packet, which is a layer 3 functionality, I had to put the MAC address on. So I put the MAC address of the router on and pinged the router. Once the router responded back, it added the ARP entry because it had to ARP for the PC as well. Remember that what my router had to do was when the ping request came up from the PC needed to do an ARP request to the router. It got it back, got the reply back, which was perfectly fine. That gave me the ARP entry on my PC. Then I sent the ping packet to the router, and the router had to reply back, which was my ICMP echo reply. That means that the router needs the MAC address of the PC. So the router turns around and does the same exact thing. Before it can send this reply back, it goes, hey, 1.100, give me your MAC. 1.100 says, here's my MAC. And that session populated the ARP cache of the router. At that point, the ping packet can be sent back and we see the reply. Now the ping packet, if you looked at it when we did it, actually did 4 replies. There's my command prompt, again, just outside there. Sorry about that. I did 4 replies here. I only did 1 ARP request. That ARP cache was populated, and for the next 2 minutes, it's going to stay there. The default is 2 minutes, so it'll be there for 2 minutes. If I ping again 2 minutes from now, it will have to re-ARP. And that's the process of resolving the address and then where we actually see it.